Hello, so we're just going to be doing some of the 6.2 integrals. And also, yeah, it'll be on Discord also, just slightly different. I think we'll begin with 5. Which will be the integral from 0 to pi over 2 of cosine squared theta d theta. So for this, we're going to need to use, what is it? The half identity. Wait.
I believe it would be the power reducing formulas.
Yeah, but yeah, it's whatever, like the 1 to the 1/2 to I think cosine's 1 plus cosine squared theta, or cosine squared x. I'm just writing the rule out.
Actually, it's cosine in parentheses 2 theta.
Okay.
Yeah, 2x. But...
And like I was telling you earlier, kind of a little rusty on those. That would equal cosine. So it's pretty good to get these reviewed right now before they start biting me again. So with this, we will take we will substitute it and take 1/2 out to the front. So from 0 to 1 over 2 of 1 plus cosine of 2 theta d theta. And then we will integrate. So that will become theta plus we're going this way. So we will have 1/2 sine of 2 theta from 0 to 1/2. And we just use the substitution rule for that, where u equals 2 theta, and that would make du equal to 1/2. Or that would make, yeah, d theta equal to 1/2. Wait, no. Yeah, it would make du over 2 equal to d theta. There we go, because du would equal 2 d theta. And then we just evaluate from 0 to 1/2. Oh, this is pi over 2. Yep, thought something was wrong. And then we simplify. So sine of pi is 0. And sine of 0 is 0. So we will get pi over 4, which is the correct answer. Okay, and from here we will move on to number 7, which is cosine of 4 2 times t dt, and the integral is from 0 to pi. All right, from this, we know that cosine to the fourth power is just cosine squared squared. So we can rewrite this from 0 to pi as cosine squared of 2t, all of this squared dt. Or we could just separate it out, but as we're just going to substitute in 1/2 times 1 plus cosine of 2 theta for cosine squared theta. We are going to have to do a u substitution here, though. So let's do that real quick, where we'll have u equal 2t, and that will mean du equals, wait. Oh,
I
yeah.
think you would have to use the power reducing formula on that again.
Well, let's see. We need to power reduce it one time, but we have this 2t right here, which means that we're going to have to in order to power reduce it, we need to make this a u. Or we should, because that will be 2 dt. Then we just said du over 2 equal to dt. And then we get from 0 to pi of cosine squared of u squared du, and we bring 1/2 out to the front. Here, actually, let me just turn off notifications.
Uh-oh. Shoot, my thing's on the fritz. That's not good.
Okay, so that looks just about, let's see. Of course, it didn't finish the pi. So I can take that half out to the front, so that'll be 1 over 4 for the integral of 0 to pi of 1 plus 2 cosine of 2u plus cosine squared of 2u du. Then I might as well, I'm thinking, wait, do we need to double? No, I just used, never mind.
You'd have to use the, I think you have to use the formula again. On cosine squared.
Yeah, this one's going to need, this one's going to need the formula again. This one's fine. I might double u this one again then. But otherwise it'll be, I mean, because we can just break this up into 2 intervals, which helps.
Mm-hmm.
And that's not going to be cosine. You know what, I'm going to break this off right here.
One half.
Oh yeah, I was just going to skip ahead and just do the 1 plus 1/2 cosine w. But since we already, yeah.
And don't forget your dw.
Yep.
dw. My least favorite Arthur character.
I'll just leave this in terms of u until we figure out the other part.
Yeah.
Because otherwise then it is way too much.
So then you would have to do multiple replacements with u and w.
Yes, because then I have to technically, send this to another thing. So this will actually be 1 over 4 of sine of 2w. Technically, this problem has like 6 or around 3 or 4 u substitutions. Because technically, this is 1 right here. This was 1. Then we had to substitute in initially right there. Oh. So I guess it's everything in terms of u. Oh, I just realized my bounds are going to be off.
So you're going to make, yeah.
Yeah, it should be beta and alpha. Because and then these are definitely off.
Then it would be for you.
Yep.
And
then this whole thing is being integrated from alpha to beta. Which now I'm just going to go through and fix these real quick. As otherwise it is going to bug me. Okay. Now we can finally go and substitute in the u, which I believe u equaled 2t. So 1/4 of 2t plus the sine of 4t plus 1 over 4 times 4t plus 1 over 4 of the sine of 8t. All of this evaluated from 0 to pi. I think it's 0 to pi, right? Yes, 0 to pi. And simplify. This all gets distributed, so that means we get 1t there, so it's 3t plus sine of 4t plus 1 over 4. Actually, that'll be 1 over 16 sine of 8t from 0 to pi. So that'll be 1 over 4, 3 times pi plus sine of 4 pi plus 1 over 16 sine of 8 pi. All of that minus 0. And then the sine of 0 is 0, and then the sine of 0 is 0, which will mean it is 3 pi plus 4 pi is going to be 0, and this is also 0, so it'll be 3 pi over 4, I believe. So let's see, because that gets turned into a 0. And 1 minute. Oh, this is supposed to be 2t. Oh no, that was supposed to be 3t, never mind. It's supposedly I'm getting the incorrect answer according to the answer guide. Did I forget to bring a 4th down somewhere along the way? let's see, 1 plus, so we both got this. Oh, except they never did the U's and W's. Okay, let's see, so I think it looks like I made this more complex than it should have been. Let's see, if I go to right here, okay, let's see, so this was my final one before I actually did anything. So 3 over 2t, okay. I forgot some substitutions somewhere. I think I just need to redo this. I'll be honest, I think I need to redo this problem again. I cannot figure out why it's not matching up. From 0 to 5, cosine of 4 times 2t dt, in which the cosine squared of theta equals 1/2 1 plus cosine of 2 theta. Going from 0 to pi of cosine, no, 1 plus cosine 2 theta squared d theta. That'll be from 0 to pi of 1 plus 2 cosine of 2 theta. Wait. Oh, no, I'm using... Okay, never mind. I see what I did wrong. So I forgot that this is supposed to be... Since it's 2t on the inside, that's going to be 4t. And I just need to restart this again, because I forgot the 1/2. So 1/2, 1 plus cosine of 2 times there, so that'll be times 2t squared plus cosine to the 4th of... I'm trying to do way too many steps at once. 1 plus cosine squared of 4t squared dt. Okay, there we go. Because there we have the theta there. If the theta is equal to 2t, then 2 theta equals 4t. then the square gets distributed out. Okay. Okay, so when we integrate it from 0 to pi, we get 1/4 times 1 plus 2 cosine squared of 4t plus cosine to the 4th power times of 4t dt. Then we can take that fourth to the front. Then that becomes 1 plus 2 cosine squared of 4t plus cosine 4 of 4t dt, in which it can be integrated. But first, this and this must be broken off again, or must be simplified. Wait.
Hold on a second. Go back up. I
Mm-hmm.
think you're making a mistake because of the power reducing formulas, you don't have a square. It's just cosine to the first power of 4t. Because if you do
Cosine.
that,
Oh yeah.
you're going to have a bad
It's gonna be.
time with
Yeah, I was
that.
about to say this looked like it was about to start cycling over and over again.
Yeah.
Did I make that mistake when I was writing this thing up here? No, I didn't, and I forgot to put the 1/2 there.
So yeah, just so I think it might be let's see. Well,
It's gonna.
actually, you can just let me see. You can take out let's see, 1/2 of one. Yeah, yeah. So you
Yeah.
take it out. You take it out twice, I think. But like you can just take out. So what I did was I just made it 1 plus cosine 4 theta squared, and I took out the 1/4 in the very beginning.
Okay. So wait 1 minute. Let me try to see. So because otherwise this is being multiplied by itself, so that means there's going to be a 1/4 over here. Or I'm just going to write it right here for the second, because that squared is that. Because this is like this squared times this squared. So this still has to get broken down, but at least it's not squared right there, so it doesn't have to keep constant. Wait, does it have the constant? No, it doesn't. It shouldn't, because after that square, it's
Actually,
gone.
I think you just add the 1/2 in, just add that 1/2 you have
Mm-hmm.
on the very left into the entire equation, and you don't need that other 1/2 next to cosine. And the
Oh,
square,
okay.
and then 1/2 squared is 1/4. You take out that 1/4.
So you're saying do this cosine of 4
And
theta.
you don't need the 1/2 cosine of 4 theta. It's just 1 plus cosine of 4 theta squared, and that 1/2
Oh
it
wait, so
comes.
wait, is there no half right there?
No, there is no half next to cosine. It's just 1/2 of that entire variable, and all
Okay.
of it is squared. And
Oh,
so
that's
what you do
perfect.
is you take the constant of 1/2 squared out.
Okay, that makes sense. So I was just messing up on my trig identities again.
Hmm.
Because yeah, okay, I see how that's gonna go. Because I thought there was supposed to be 1/2 right there, but
Nah, you have to. You're gonna
yeah.
have a bad time if you do that.
Oh, I'm gonna have a terrible time if I do that.
Yeah. So then when you take the 1/4 out,
Mhm.
then
Well,
you get just 1
I-
plus cosine of
I'm gonna just
4t.
do every step just so I don't mess it up, because otherwise I know I will mess it
Okay.
up. Because this will just become, well, actually, well, I might mess it up. It depends, because this is nice and easy. Oh wait, no, it isn't.
Well, if you just expand it now and then
Yeah.
take out the 1/4 out of the so yeah.
of cosine. Oh wait, no, that shouldn't. This one shouldn't be squared. Only this one should be squared.
Yeah, I think that's just 1 because 1/2.
And that should be 8. No, 8t or 4. 1 minute. So if no, only I believe this should be 4t to begin with, just because it's multiplying by itself. I forgot the dt there. And then because from here I then need to go and break this one back down again through whatever the mechanism's called.
Okay, so actually, for that binomial, the middle factor would have a coefficient of 1/2 because what happens when you multiply the first by the second
Oh
in
yeah.
that
Oh, that is
binomial?
so true. So that'll be 2. Well, no, it's going to be 2/2 though, because I was. Oh wait, no, I forgot about this half right here. So it's still going to be. So 1/2. That's 1/4. So this should be 1/2.
Mm-hmm.
Okay, that makes sense. That would be where I'm messing up. Because then if you pull a fourth out of everything, this gets doubled. Okay, and then it's finally then this has to be expanded.
So split the integral between 1 plus 2 cosine 4t dt,
Mm-hmm. So
and
that'll.
then don't forget your dt over there.
Mm-hmm.
And then, yeah, well,
Plus
let's see.
1/2 times 1 plus cosine, and then this will be 8t.
Mm-hmm.
Okay, so that's that one. Then I need to do this, and then it's dt.
Okay.
Okay, so then it'll be 1/4 from 0 to pi. 1 plus, oh, that's not a plus. 2 cosine 4t plus 1/2 plus 1/2 cosine of 8t dt. Okay, now this has to be brought on over since that's 1/2. That will be from 1/4 0 to pi 3/2 plus 2 cosine of 4t
What might be more powerful point if I change
plus
my variables?
1/2
Look at my
8t
variables.
dt.
Oops, it's bad notation.
Now, then it's time to integrate. So that'll be 3t/2 plus 2/4
Mm-hmm.
sine of 4t. I don't know why I'm writing my 4s like t's today. Plus 8/4 t squared, all from 0 to pi. So that'll be 1/4. Oh wait, no. Oh, I'm forgetting. That looked a little too simple. That was the 1/2 cosine 8t.
Mm. Yeah.
So instead, that'll be 1/2 times 1/8 of sine of 8t
Yeah.
dt. Oh, and there's no dt. That's supposed to be an evaluation from 0 to pi. And then we can substitute everything in. So we get 1/4 So this becomes 3 pi over 4, no, over 2, plus sine of 4 pi is 0, and then same is for pi, no, of sine of 8 pi, 8 pi, and then 0 of everything is going to be 0. Which means we get 3 over 8 pi, which is the correct answer.
Yep. I
Okay,
can agree.
that took way too long, and I just can't believe I made that many stupid mistakes. At least I got them through, and hopefully I don't make that
All
same
right.
mistake right there again.
You just have to remember, if that comes up on the test tomorrow, you have to remember your power formulas. Otherwise, you're not going to really finish this question in time.
Oh yeah, I will not
So,
have a good time at all.
yeah.
Okay, guess on to the next problem, which will be 9. Since there's only 1, 2, 3, 4, 5 problems listed here, and I already did 1 and 2, and actually those were not that bad. Did 5, so this will be the last one from this set before going on to the challenge. And I should probably put my black back on. Zero to pi over 2 of sine squared x cosine squared x dx. So let's see, so sine squared x equals, this is the 1/2 of 1 minus cosine of 2x. So I will change that over, so I will rewrite this as, or I will substitute that in, so from the limit of 0 to pi over 2 of 1/2 times 1 minus cosine of 2x times cosine squared x dx, in which I can then bring that 1/2 out to the front. Then I can set u equal to cosine of x. And I can't do that yet. Never mind. I need to probably just...
Well, notice that both of them are even. So I believe you can do. So what does that mean
Well,
exactly?
from up here, if this was even, then we could have just taken the limit, but it's already from 0 to pi over 2. That's the issue.
But what about power reducing formulas?
Oh, we could also take the power reducing formula of cosine squared of x.
And for your sine conversion, I believe the negative applies to the 1, not the cosine.
Okay, here, I'm going to look that one up real quick, because it could, I thought it was, unless they normally rate it out with that negative half in front. Let's take a look. That will be in partial fractions. Oh, wait, no, it won't be in partial fractions. It'll be in 6.2.
Wait, no, he's right.
I am right?
Oh yeah, I think so, with the 1 minus.
Well, we can always just double check. I have it in the notes right here. Okay, so sine squared of x equals 1/2 1 minus cosine of 2x. So yeah, I got it right.
Yeah, I think, yeah, my mistake
Yep, all good. It's always good to double check than to
then.
be uncertain. I think it might just be easier to take cosine squared of x use the power reducing formula. Again, because then I don't have to worry about making this right here into a U and then all that.
Ooh.
Which I can then make that 1/4 from 0 to pi over 2 times 1 minus cosine of 2x, all of that times 1 plus the cosine of 2x dx. And then that makes it a really nice and simple multiplication together. So it's from these, so 1 over 4 times the integral of 0 to pi over 2 times 1, and then because these cancel out, it'll just go right to plus, wait, 1 minute, so no, 1 minus cosine squared of 2x. That should be it, if I'm correct. Um, Here, let's see, because yeah, because I'm not taking the derivative yet. That should be fine. Because I don't think the 2x is on the inside multiply, right? When you multiply cos, 1 minute, let's see, cosine 2x times cosine 2x. Yeah, it just squares, never mind. Yeah, that just, yeah, that is 100% just squaring, because that's pretty much like, it's just a constant. And then that can be broken back down through the power reduction. And then that will have to be distributed. Oh, and that should be a plus, not a minus. So that'll be minus 1/2 being distributed to those. Then simplify this couple of terms together. So that will be 1/2 minus 1/2 cosine 2x dx, which means that a 1/2 can get brought out, so it'll be 1 over 8 from 0 to pi over 2, 1 minus cosine of 2x dx. And that is then integrable, so we can take the integral of it. It'll be x minus, and cosine that'll be 1 over 2, or yeah, 1 over 2 sine of x, or no, sine of 2x from 0 to pi over 2. Here, let me just, I just want to rework this one. I think it should be correct because of the chain. Yeah, that's fine because of the, not chain rule, the U substitution. So 1 over 8 x minus 1/2 sine of 2x from 0 to pi over 2. Then we evaluate, so 1 over 8, so that means we get pi over 2 minus, the sine of pi is going to be 0, so minus 0, minus, and then 0 times x is 0, and then the sine of 0 is 0, So we get pi over 16, and that is the correct answer. Even though I'm taking a look, and I believe the textbook did it in a slightly different way, so truly doesn't. I think this was just fine. May have taken a little longer than should have. Oh wait, no, we got plenty more questions. Oh, that's nice. Guess it's time for question 23. Question 23 is the integral of 0 to pi over 3 of tangent 5x times secant 4x dx. So what we're going to want to begin doing is breaking the tangent into a tangent squared. Wait, 1 minute. 1 minute. Let me write the rule real quick. So tan squared x plus 1 equals secant squared x, I believe. No, it doesn't feel right. Nope, 1 minute. Doesn't feel like, but my instincts are telling me that it's right. So we can just check that real quick. Yeah, it is right. Because I should not doubt myself, but... So we're going to take the integral of 0 to pi over 3, tangent squared x, tangent to the third power x, secant to the 4x, or 4 times, of secant to the fourth power of x dx. Then we will take what we can and, well actually, do we want to take, no, I don't think we want to take the tangent. I think it might be easier to break the secant off. Just because that is then, yeah, because we have most of it in the tangent, so. Okay, yeah, because then when we take the derivative of tangent, we'll get secant squared x, which will help out. So we're going to get the integral of 0 to pi over 3 of tangent to the 5x minus tangent to the 7x secant squared x dx, where we're going to want to set u equal to tangent x, and du is going to be equal to then secant squared x dx. So we're going to get from, we could evaluate u at these points, but I'm just going to use alpha and beta of u to the 5th minus u to the 7th du. And then this is really nice and easy to integrate. So u to the 6 over 6 minus u to the 8 over 8 from alpha to beta. And then we put tangent back in. So we're going to have tangent to the 6 x over 6 minus tangent 8x over 6 from 0 to pi over 3. And then we will input. So we're going to have tangent 6 of pi over 3 over 6 minus tangent 8 of pi over 3 over 8 minus tangent 6 of 0, no, not theta, 0 over 6 minus tangent 8 of 0 over 8. All right, so then we have, I just drew out a bit of a unit circle, just the first quadrant. So we're going to be using this one right here. Actually, no, we're not going to use that. That's pi over 6. We're going to use this one right here for pi over 6. I just like this because then I know for sure that I can visualize it and know for sure, because 1/2 is smallest, so that means cosine is going to be smallest. Which this will mean, because tangent equals sine over cosine, that was going to equal root 3 over 1, which means that this will be root 3 to the 6th power over 6 minus root 3 to the 8th power over 8 minus tangent to the 0 will have is actually not really able to get it because cosine is equal to 0. So this is all just going to be 0. All right, and let me just take a look. Oh, did this not have evaluation? Oh yeah, it was asking to evaluate. I feel like I did something wrong.
What trig what trig substitution did you do?
I use secant squared x equals 1 minus tangent squared x.
All right,
Because,
so I think that's where your problem lies.
okay, and why is that?
Because, all right,
Is it,
because um, it's supposed to be a positive tangent squared x.
wait, oh, that would explain it, because I literally wrote it right correct up here, and then I wrote it incorrect down here.
Yeah.
I'm just making the stupidest of mistakes. I need more sleep, or something, I don't know.
That's all right. Hopefully, you can get maybe some study time in before the quiz.
Well, that's what this is for.
Yeah.
If I make all my stupid mistakes now for everyone to see, then I'm pretty sure I'm not going to make them again later on that test. So we're just going to ignore this section and then take
Yeah.
that over to there. At least you're able to catch them and tell me exactly what I did wrong every single time.
Yeah, I suppose. But it'll be up to you to know that.
Yeah, I mean, on the quiz, it should be okay to do. It's not going to
I
be the
did it.
easiest thing, but
Made a silly mistake on the last quiz, and I real, because it's the small stuff.
yep. I mean, that's how I lose most of my points on the quizzes.
Yeah.
And then this has been the first quiz I wish I'd say has actually been a pain, because I've been so focused on the exam and not for the quiz. I have not studied this part of the material that much, and I'm going to be regretting it. Okay. No, and that's not going to be a plus. It's just going to be secant squared x dx. Okay, so we substituted secant squared x with tan squared x plus 1. Correct way this time. Now we're going to distribute. So went from 0 to pi over 3 of tangent of 7x plus tangent of 5x times secant squared x dx, where we're going to set u equal to tangent of x, and then that will mean du equals secant squared x dx. So we get, matter of fact, we can probably just, I'm saying just get the new bounds now, just so I don't have to go back. So tangent of pi over 3 is root 3. Tangent of 0 is... Wait. Does tangent of 0 even... Tangent of 0 is just 0. Wait, am I even taking... I think I'm taking the right derivative, right? So tangent of x equals... when you take the derivative of that, is that secant squared x?
Yes, that's correct.
Okay. So I guess the new bounds are from 0 to root 3 then. So when we substitute that in, we're going to get the bounds from 0 to root 3 of u to the 7th power plus u to the 5th power du. And then we integrate it, so that'll be u to the 8th over 8 plus u to the 6 over 6 from root 3, no, from 0 to root 3, which will be root 3 to the 8th power over 8 plus root 3 to the 6th power over 6. And then the rest is going to be 0, because 0 times to any power, in this case, is going to be 0. Okay. Okay, so that'll be I could just cut the power in half to deal with that. So that'll be 3 to the 4th over 8 plus 3 to the 3rd over 6th over 6, and 3 times 3 it will be 6 times 3 again is going to be 18 times 3 again equals 54. Oh, I don't even have to, oh yeah, I need to get that high. So 54 over 8 plus 18 over 6, I think. No, I'd failed math. 3 times 3 is 6. Then times, wait. No, wait. It's 9. That's what I was messing up on. I was, 9, 27. 27 times 3. I think that's going to be, yeah, 81. Okay. Then if I multiply this, I can simplify this a little bit, so it'll be 81 over 8 plus, because I can divide by 3 on each side, so that'll be 18 over 2. Wait. No, 27 divided by 3, that's 9. No, it's not. Or 27 divided by, oh, but it's being divided by 3. Yeah, no, never mind, it's 9. Okay, so 162 over 16 plus 9 times 8 equal to 72. 72 over over 16. That'll be 4, 6, 7, 8, 9, 10, 11, 12, 13. 16, take out a 2. $117. Oh, and that's not over 2, that's over 8. Okay. And that is the correct answer. So I think I'm going to honestly take a break because I cannot keep thinking. I'm just too tired. I need to grab something to eat and all that.